This notebook was written between Joe Taylor and myself, and it was also based on the notebooks by Brian Hilbert. So it has pretty much the same layout than the Spec 2 notebook that Joe just went through. So in the interest of time, I'm going to skip through a lot of information that is here basically for completeness, so that you don't have to, if you want to run Spec 3 and you come back and look for this, all the information is also here. You have to open another notebook. But like I said, the information is the same. And just like the Spec 2 notebook, none of these cells are really meant to be run. So they're just there for informational purposes. As a general information, the input to Spec 3, CalWeb Spec 3, which I'm going to call Spec 3 from now on, the input is the cal files, the calibrated files that you get from Spec 2. And you input those, which are exposure-based, to the pipeline via an association file. I'll explain to you very briefly what is an association file. Like I said, I'm skipping through all this information, but you can always come back and look through. These are all the inputs that you would use to call the pipeline as a whole or individual steps. Okay, so an association file is really a text file in the form of a JSON file that is really a Python dictionary, if you're familiar with those, in which you can tell the pipeline which files you want it to use to combine to generate your output, your calibrated and rectified output. And you can tell the pipeline if those are, if it's a target acquisition, if it's a background, if it's a, you tell the pipeline what each file is via those files. You don't have to worry about creating these files. These files will be automatically created by the pipeline, and you will be able to download all of these files with your data from MAST. But if you wanted to see how to create an association file, here's an example on how to do that. The methods for calling the pipeline are the same as previously described by Joe. Right, so onto the individual steps. So first, we have the assign WCS for moving targets. So as the name suggests, this is only applied to moving targets. And what this step does is modify the WCS output frame in each exposure of the moving target observation, so that the WCS is centered at the average location of the target within the whole association. And this is done at the beginning of Spec 3, because then later steps will rely on this WCS information centered on the target. Right, so the master background step, the algorithm is the same as Joe described for Spec 2, and it will be applied for NIRSpec MOS during Spec 2, but it's generally done at this stage, at stage 3. And so, it's the same algorithm that she just described. Okay, so exposure to source step. This step reorganizes the outputs from Spec 2 that are exposure-based into source-based data. So it is only used when there is known source list for the exposure data. It is only used for MOS and fixed slit and wide field slit lists. The MiriMRS Sky Matching step This step matches the image intensities of several input 2D MiriMRS images by fitting polynomials to cube intensities in such a way as to minimize the inter-image mismatches in intensity. And you can, well, by default, the backgrounds are not subtracted from the exposure data, but you can tell the pipeline to do so. The outlier detection step. This step uses a collection of input files to identify and flag any cosmic rays or any other transient artifacts that were not flagged during the jump step in detector 1 pipeline. And the bad pixel, so to speak, will be flagged in the DQ map and will later be ignored when the exposures are combined for final mosaic. The resample step, this step resamples each 2D image based on the WCS and the distortion information and combines multiple resample images into a single undistorted product. The cube build step. The algorithm is the same as this step in Spec 2. The difference is that the input in Spec 3, it can be a collection of data from multiple exposures covering multiple bands. So, of course, this is only applied for IFU data. The 1D extraction step. This step extracts a 1D signal from a 2D or 3D data set and writes spectral data to an output 1D extracted spectral product. And finally, the 1D spectral combination step. It computes a weighted average of 1D spectra and then writes a combined 1D spectrum output. And this weighted average is typically the integration time or the exposure time, but it can also be specified instead by the user, and it is only applied for NIRS and NIRCam data.